We're now looking at volumes of pyramids and cones, and the nice thing about these equations is it's just basically the same as the formulas for a prism and a cylinder, but it's 1/3 of the size. So the volume of a pyramid is 1/3 the volume of a prism that has the same area of the base and the same height. And for a cone, it has 1/3 the volume of a cylinder with the same base and the same height. So for this figure right here that we're going to put up, we have a pyramid. So our formula is going to be 1/3 area of the base times the height. Remember that we need to figure out the area of the base off to the side, and since this is a right triangle, we know that the base is 4 and the height is 6 for the triangle. We're going to use 1/2 base times height. So in this case it would be 1/2 4 times 6, and if we do half of 4 we get 2 here. That gives us 12 square meters. Our height is given to us, luckily. Straight up and down is 9 meters. We just plug everything in. We have 1/3. The area of the base is 12. The height is 9. I'm going to go ahead and do 1/3 of 12 is 4. So that gives us a total of 36 cubic meters. So if we look again, 1/3 area of the base times the height, we plug everything in, we get 36 square meters, or cubic meters, sorry. Remember, Cavalieri's principle holds up here, so even though it's slanted, we just look at the radius and the height and we have our answer. So again, since it's a cone, it's 1/3 pi r squared h. Our radius here is 2.2 centimeters, and our height is 4.5 centimeters. This is going to give us 1/3 pi times the radius, which is 2.2 squared, times the height, which is 4.5. I'm going to go ahead and, I know that 4.5 is divisible by 3 because 45 is divisible by 3. So I'm going to do 4.5 divided by 3, and I'm going to get 1.5. So I'm going to cancel those out and call that 1.5. And then I'm going to multiply 2.2 squared. So 2.2 squared times 1.5. We get 7.26 pi. Make sure you put it in this format and make sure it makes us know that you're doing it right. And then the last step should be multiplying times pi. So if I multiply times pi, I end up with 22.81 if we round to the nearest hundredth, and that would be cubic centimeters. So again, plug it all in, 7.26 cubic centimeters times pi, which gives us 22.81. And let's take a look at this. We have our volume, we have our height, we want to find the side length of the square base. So basically what we want to do is find the area of the base, and then once we do that, we can take the square root of that and get our answer. So our formula again is volume equals 1/3 area of the base times the height. We know this is 2,226,450. Over here we're going to have 1/3. The area of the base we don't know, but we know the height is 144. I believe that 144 is divisible by 3, so I'm going to go ahead and do that. And we get 48 for this. So we're going to have 48b equals 2,226,450. We're going to divide both sides by 48. Hopefully this goes in evenly. So we get the area of the base, 2,226,450 divided by 48, and it goes in somewhat evenly. We get 46,384.375. That's the area of the base. Now the base is a square, therefore it would be side squared, and we want to know what the length of one of those sides is. So we're going to take that 46,384.375, and we're going to set it equal to s squared. If we take the square root of both sides, and I'll do that right now. Give me one sec. Square root. Oops. Let's see. So we have square root of 46,384.375. And if we round this, we get about 215.37, and I don't remember what the units were. Meters. Okay. So that's the length of one side there. So again, we write out our formula. We substitute in our values. They just put the x squared in there right away. And we divide by 144, take the square root. We get about 215. I got something pretty much the same thing. I got 215.37. So we're good there. And here's another one where we have to find the volume. For this one, remember again, it's volume equals 1/3 area of the base times the height. To find the area of the base, we're going to have to do 1/2 AP. And we know the length of one side is 4. I'm going to go ahead and pull out a hexagon here. If you give me just a sec. Go ahead and get a hexagon ready. There's my hexagon. Okay. So we're going to use this shape, and remember again, we know the length of each side is 4. If I draw from the center, I draw a line here and a line here. We know this is an equilateral triangle because this angle will be 60 and it's isosceles. That makes those two angles 60 as well. If I draw a line going straight down, we've created two 30, 60, 90 triangles where this length is 2, this length is 4, and the apothem is 2 rad 3. Our perimeter will be found by doing 4 times the number of sides, which is 6. So we get 24 yards there. For here, we get 1/2 times the apothem, which is 2 rad 3. And the perimeter is 24. I'm going to go ahead and just cancel out the 1/2 and the 2. And we get 24 rad 3 for the area of the base. Our height ends up being 11 yards. So we have 1/3 times 24 rad 3 times 11. I'm going to simplify one more time and give this an 8 here, because 1/3 of 24 is 8. This gives us 88 rad 3 cubic yards. If I then get my calculator and I do 88 times rad 3, I get 152.42 cubic yards. Okay? 152.42. Here's another one with a right cone. If you notice, they don't give us the height here, and we do need the height. because the formula is pi 1/3 pi r squared times the height. So we're going to have to use Pythagorean theorem because you notice this is a right triangle. So if I call this h, I can say h squared plus 5 squared equals 8 squared, or h squared plus 25 equals 64. We're going to subtract out 25. And we get h squared here. Over here, we would have 9, and 5 minus 2 is 39. So the square root of 39, I'm just going to go ahead and leave it like that for right now. That's our height. We know what our radius is. Our radius is 5. This time we're not going to be able to cancel anything out, so we're just going to keep it as is. We have 1/3 times pi times 5 squared times rad 39. So we're going to have 25 rad 39 times pi over 3. And that's where we get our calculator out. And we have 25 times rad 39 times pi, and we divide that by 3. Should get approximately 92.24 cubic meters. Okay. Oh, I got a different answer. Let's go back and look where we went wrong. Let's see. I'm going to have to start over, probably. So let's see. Let's try that again. 25 times rad 39. Oh, that's part of the problem. 25 times rad 39 equals times pi equals divided by 3. I don't know where I went wrong before. Sorry about that. Sometimes you make those mistakes. We get 163.49. I apologize for the mistake there. Cubic meters, 163.49. And here's the last one. Luckily, they left this for us in terms of pi. So we know the formula here is volume equals 1/3 pi r squared times the height. They give us the radius and they give us the volume. So we're going to plug those in. We get 1350 pi. And that equals 1/3 pi times the radius, which is 18 squared, times the height. Now, when you do a problem like this, oops, we don't need that. Make sure that, oh, that is 18, sorry. Make sure that you do not divide 18 and 3 until after you've squared it. So we get 1350 pi, and we get, whoops, that's equal to 1/3 pi times 18 squared, and 18 squared is 324 times the height. Now I'm going to divide these two, and that gives me 108. So I'm going to have 1350 pi. That's equal to 108 pi times h. We're going to divide both sides by 108 pi. You notice I've left everything in terms of pi. I did that on purpose because the pi's will now cancel out. If you multiply this and then divide the two, it's going to end up making your answer be off. So make sure that you keep everything in terms of pi until you need to. So really all we're doing here is dividing 1350 by 108. So if we do that, we get 1350 divided by 108, and we get 12.5. If you do this with the pi's in there, it may end up coming out to be something like 12.499 or something like that. The units here are meters. Okay, and there's the height, and we're done. Thanks.